Good morning or good afternoon, everybody. Hope you're doing good here as we continue to move through section 7.4. Hey, thank you for submitting using Google Docs, using Cam Scanner. You have no idea how that makes my world a little bit easier. And if you're not doing that, please make sure you do that for every assignment, be it a homework or a quiz or a test or anything. Okay, just kind of keeps everything in order. All right, what I'm going to try and start to do as we move forward is I have posted the answer key to the previous homework on Canvas, right on that actual the assignment and module. And then today, I'll just put it on the video. So here was the assignment from yesterday, in dealing with the IJ method and then converting from IJ to magnitude and direction. And so you can take a second, go through your homework, or you can go back on Canvas, pull up the answer sheet, print it off. Whatever you need to do, make sure you're getting these right. So there's 47, 49, and 51. Kind of going through there. Remember, 51 is a magnitude. It will be a single quantity. 57 and 59, converting from IJ form to magnitude and direction. If it is not a unit circle angle, you're going to have to use your calculator, 67.38 degrees. Now for 61 and 63, these are both unit circle angles, so they can we can use the exact values. Cosine of 30, sine of 30. Doesn't go away for a long time. Okay, we're not done with that. Cosine of 120, sine of 120. All right, we are going to move into the last thing, which is application problems of vectors. I'm going to get out of here for a second. So down here at the bottom, use vector, and like I said, we could probably spend multiple days on this. We're going to hit it. You're going to have the opportunity to review it, and then we're going to do section 7.5 next week, and then we're going to have a test. Okay, I believe it is next Thursday. We're going to have a test over 7.1 to 7.5. Now we did skip 7.3, and that's fine. We're not going to go back to it at all. So don't even worry about 7.3. All right, so vectors and applications. There was that homework key. All right, you physics kids. Like I said, I'm not sure whether you've hit it now or if you hit it later, but if you hit it earlier, great. And if you're going to hit it later, at least you've had a touch of it. A fundamental principle of physics is that the effect of two forces acting on a body is the sum of the forces. So if you get two people pushing on a stalled car, both forces will add together to either move the car or attempt to move the car. Sum means what it always means. It means addition. We are going to add the forces. Well, the forces can be represented by vectors. Well, just to kind of give you a visual, we'll go to one of my favorite Twitter people, Rex Chapman. And this is a segment called Block or Charge, and it's usually dumb people doing dumb things and the results that happen. And so these are two forces running at each other. And remember, football kids, lower man always wins, or girl. So right there, that's the effect of the forces. And another example. And most of these do not end well. Oh. So you take a look here, we got a rolling tire. We got some kid attempting to stop it, and obviously he loses. And a third one. For you beachgoers, I'm sure you've all experienced this at some point. Ooh. All right. The guy is one force. The wave is the other force. Obviously, the wave wins this one. Right there. Oh, okay. Those are examples of two forces coming together. Two forces kind of acting on each other, and you can see the result of the two forces. That would be the same. We can also have two forces acting on a body. Okay. Um, Hopefully you printed off those guided notes. Okay, it just lists the problems. We're going to go through three of them today. Two forces are acting on a body. One force has a direction of 130 degrees and a magnitude of 100 pounds. The second force has a direction of 200 degrees and a magnitude of 70 pounds. Find the resultant force and direction. All right, here's your two forces down here. Okay, this first one, and I'm going to, is 100 pounds. The second one is 70 at a direction of 200 degrees. What you can do is you can think of it, there's a body at the origin right there. Now, if those two forces, that's a rock, I don't know, it's a stalled car, those two forces are pushing on that body. Where is it going to move? Okay, where is it going to move? So it's going to move to the sum of the two forces. Okay, so if you think about it, it doesn't make any sense for the body. It's not going to go that direction. Okay, it's not going to go straight, almost straight down. It's going to go somewhere in between those two forces. They're going to, it's not going to go directly this way because the other force is going to push it that way. And it's not going to go directly this way because the other force is pushing it this way. It's going to fall somewhere between the middle. Now, we did two ways to add forces, and depending on the situation, will depend on which way, what we want to use. Let me get rid of this force right here in a second. All right, so the two forces are acting on that body. Normally, we add them tip to tail, and they'll both work. So I can take this force and move it to the end terminal point of that force, and the resultant force will be this force right here. So geometrically, that's our answer. That's the direction it's going to move. Okay. And then when you have two forces acting in a body, sometimes a parallelogram method is better to visualize it because the two forces are acting together. So they're acting right here. Now what I can do, if I do the parallelogram method, I can clone that and move it to the end of this force. I can clone this force and move it to the end. But the force going through the diagonal is the sum. All right, so however you get this geometric sum, it's kind of good to have a picture. All right, as you take a look at it, now I drew these somewhat accurate, so we kind of have a good idea where it's going to end up. Sometimes you don't have to draw it out. And so sometimes there's going to be a question of which quadrant that force is in. Here's pretty clear it's going to be in quadrant 2. But like I said, in some cases, it's going to be very close to an axis. You're not going to be able to determine. All right, here's how we find the resultant force. We said the first one is 100 pounds, and the second one is 70. All right, let me call the first one U. So U is 100 pounds. Now we're going to convert this to IJ form. So we're going to take the cosine of 130 degrees I plus the sine of 130 degrees J. Okay, so we're going to convert them both to IJ form. We're going to add them together. In the end, we need the resultant force and direction. Now remember, direction is off of the x-axis. So that means that angle right there is 130 degrees. It means the angle to the red vector is 200 degrees. Okay, for that, that's very important because sometimes we'll talk about bearing and sometimes we'll talk about direction. All right, use your calculator. Multiply 100. We're going to round everything in the problem and the final answer to 2 decimal places. So take 100 times cosine of 130. Okay, and then I'm going to take 100 times the sine of 130. Now it's important that you use the direction because that will give us the actual angle. Okay, that'll give us or the whether it's positive or negative. I'm just going to move this here so that I have it while I write this down. All right, so now U is negative 64.28I, and then that's a positive value, so plus 76.60J. So there's your U vector. We've converted it to IJ form. All right, do the same thing for the V vector. So for the V vector, that is the magnitude, okay, times the cosine of the direction. The direction for that is 200 degrees. So cosine of 200 degrees I plus sine of 200 degrees J. Okay, that is how we convert to IJ form. So vector V. All right, so take 70 times 200, or a cosine of 200, and then take 70 times sine of 200. Well, both answers should be negative because that vector is in quadrant 3. The endpoint is in quadrant 3. With the other vector, the first vector U, it should have been a negative x, or a negative first term I, and a positive j because it's in quadrant 2. So we got negative 65.78 I, and then we got minus 23.94 j. All right, now to find the resultant vector. Now we already know where it's at in that, we have a good idea where it's at. All right, to find the resultant vector, you take vector U plus vector V, which means you add the I parts together, you add the J parts together. So it's going to be, now normally I wouldn't write this out, but since I'm not physically in front of you, I'm going to. So as you take those two plus 76.60 minus 23.94 J. All right, so when you add those together, I get negative 130.06 I plus 52. Let's see. What do we get for that second one there? I disagree what I got down. 76.60 minus 23.94. Oh, it shouldn't be negative. Sorry. 76.60 minus 23.94. 52.66. So plus 52.66 J. All right, so that is in IJ form the answer to the problem. What quadrant is that in? Now, we suspected it would be in quadrant 2 because of how we drew the figure. Right now, since that's a negative and a positive, you absolutely know that's going to be in quadrant 2. That's going to be very important for the direction. All right, the problem says find the resultant force and direction. All right, I need to know the pounds, okay, and I need to know the direction. Okay, is it 100 degrees? Is it 200 degrees? Obviously, it's going to be somewhere between there. Okay, basically to find the force, you find the magnitude. So we need to find the magnitude of U plus V. And that's going to be the square root of negative 130.06 squared plus 52.66 squared. All right, take a second to find it. And don't just sit here and let me do all the calculations for you. It's going to be helpful if you do them on your own and then just verify. And squared plus 52.66 squared. All right, I got 140.32. 140.32 pounds. Okay. we know, and I'm going to just let's just say this is the resultant vector right there. Okay. That vector is right here. We know it's 140.32 in terms of the length. The direction, this is the direction right here. Unless it's in quadrant 1, you cannot find the direction directly. You have to find the reference angle and then find the direction. So we need to find this reference angle, and it's always based upon that right triangle. Here's your J part, 52.66. Here's your I point. Okay, and now the reference angle is going to be the inverse tangent of the absolute value. Okay, we're not going to mess around with positives and negatives. So you take the absolute value of 52.66 over, and you can just drop the negative. Technically, it's negative 30.06, but when I plug it in, I'm going to drop the negative. So inverse tangent 52.66 divided by 130.06. And that's going to give me 22.04 degrees. That is the reference angle. Okay, that is theta prime right here. But the angle itself, since it's a quadrant 2, the actual direction will be 180 minus 22.04, so which is 157.96. Okay, force, right? The resultant force and direction. So the force is 140.32 pounds, and the direction is 157.96 degrees. Okay, so that's how we take two vectors, two forces, and we convert them to vectors, and we just add those together. That's the basis for it. Yeah, it can get a little bit different, and then the scenarios are going to be different as well, which we have to be able to interpret correctly. All right, let's take a look here at the next one. Two tugboats are maneuvering a supply barge through a channel. Maybe they have chains hooked to it. Maybe they're pushing it. One tugboat exerts a force of 900 pounds with a direction of 80 degrees. Okay, 900 pounds with a direction of 80 degrees. That would be this vector I have here. The other tugboat exerts a force of 1,200 pounds with a direction of 165 degrees. Okay, I believe I did draw these somewhat to scale, maybe exactly to scale. I can't remember. But in this case here, we want the resultant force. The resultant force has to be between those two. Now we could run into a situation where it comes close to the y-axis. I think it's going to be more in quadrant 2. Now, since you have two forces acting on a body, it's easier to understand as you draw it from here. But if you're going to add them, and I have a little bit of an advantage because I can just do this. I can slide that, and then I'm going to draw the resultant force, which is right here. There's your resultant force. Now for me, and you could create the parallelogram, that's fine. But since I can, and using SmartBoard, I'm just going to slide that back there just so I can have a visual. So there you got 1,200, you got 900. Right there, that black vector is going to be the resultant force. It's obviously bigger than both 1,200 and 900. And then the angle is going to be somewhere between 90 and 180, or yep, because it's in quadrant 2. All right, vector U. I'll call vector U the one in quadrant, the first one given. Now we want to convert to IJ form. Magnitude of 900 times cosine of 80 degrees I plus sine of 80 degrees J. And I'm going to finish that in a second, but I'm just going to write this down. V is 1,200 times cosine of 165 I plus sine of 165 J. All right, I'm going to pause this. You use your calculator. You figure out what it is. Okay, So hopefully you got U is 156.28 I plus 886.33 J. And then V is negative 1159.11 I plus 310.58 J. All right, we need to find the magnitude. We need to add them together. That's the resultant force. So we need to find U plus V. All right, so if you do 156.28 minus 1159.11, I got negative 1002.83 I. And then I got plus 1196.91 J. What quadrant is that in? And I know we have it drawn over there, so you kind of get it. Don't even look over there because that's a negative and that's a positive. This has to be in quadrant 2. Okay, that's going to be important when it comes to finding our direction. All right, what's the magnitude of U plus V? It's going to be the square root negative 1002.83 squared plus 1196.91 quantity squared. Take the square root. I think I'll take the square root last. Plus 1196.91. Okay, and now I'm going to do second square root, second answer, 1561.491. 1561.49. And since the original forces were in pounds, this force will be in pounds. All right, your direction. Theta prime, your reference angle is going to be the tangent inverse of the kind of the y part or the j, 1196.9. Whoops, let me fix that. 1196.91 divided by negative 1002.83. And yes, we do not use the negative. We take the absolute value. So inverse tangent, 1196 divided by 1002.83. And I get 50.02. Is that right? Oh, I didn't put 0.91 on there. So inverse tangent 1196.91 divided by 1002.83, 50.04. All right, a couple hundreds. Okay, that is this angle right there. So our direction for this problem is going to be 180 minus 50.04, which is going to be 129.96 degrees. All right, so we got our force. All right, we got our magnitude, and which is 1,561.49 pounds. And we got our direction, which is 129.96. Oops, that's a 9 degrees. All right, so those are two cases, two forces are acting on a single body. Okay. Now we have the last one that we're going to do. A little bit different scenario. A plane is flying at a speed of 450 miles per hour at a bearing of south 50 degrees west. If there's a west wind blowing at 30 miles per hour, find the plane's ground speed and bearing. Okay, this is the direction it's actually heading, the bearing. The wind is going to affect it. The wind is going to push it off course a little bit. We have to figure out how far off course it's pushing it and what its new bearing is and what its new speed is. So if there is no in still air, there is no wind, it'd be flying 450 miles per hour. But the wind is going to affect that. Now, dealing with wind. Now, a couple here. This is a bearing. The other two problems are direction. This is different. We got to be careful here. Winds, that is the direction it's coming from. We will have to attach a direction to it. So a west wind, okay, if you look at it, is coming from the west. Okay, it is coming from the west, basically west to east. So it's coming this direction. Okay, for that, that would be a west wind. But for both of these, and for when we add vectors in the ij form, we have to convert them to ij form. We have to put it in direction. Okay. And so right now that is a bearing, south 50 degrees west. So south 50 degrees west. That means this is 50 degrees. What is its direction? So for south 50 degrees west, okay, the direction is right here. Well, if that's 50 degrees, that means in here has to be 40. And you take 180 plus 40 is 220 degrees. We have to use a direction of 40 degrees. A west wind. What is its direction? Well, I actually have it drawn down here, the little blue vector. That is a direction of 0 degrees. That is important. All right, now once we got everything in terms of direction, we can go to ij form, add them together. So let's call the plane's speed. We can let the speed be represented by a vector. Okay, here is the wind. Okay, now I'm going to move the wind to here. And the wind, that's going to how it's going to affect the plane. It's kind of going to push it back, push it towards the axis. Here's the resultant vector. Okay, now I'm going to move my wind back here. Well, I don't know. Let's just leave it in this case for this. It makes a little more sense to me when we're dealing with a plane and the wind to leave it in this form. You don't have like, we're not moving a single body. So here's your one. So the speed is our force. And what is the speed of it? It's 450. And then the speed of the wind is 30. So as you take a look at it, is that resultant vector going to be more or less than 450? Let me think about it and see if the answer makes sense. Okay, the wind is either going to increase the speed or it's going to decrease it. All right, so for the first one, U converted to ij form. So 450 will serve as the magnitude. Cosine 220 degrees I plus sine 220 degrees J. And then go ahead and let's calculate that in a second. V is 30 degrees. And that is cosine 0 degrees I plus sine of 0 degrees J. Okay, calculator. 450 cosine 220. And then 450 times sine 220. Okay, and so that gives me U equals negative 344.72 I. Minus 289.25 J. All right, V. What's cosine of 0 degrees? Cosine of 0 degrees should be 1. So this is going to be 30 times 1I, which is 30I. And the sine of 0 degrees is 0. Okay, so if you take the sine of 0, it's going to be 0. So that's basically plus 0J. As you take a look at that, would be the coordinates of the point if we put it at the origin. Okay, 30, 0 for that one. Now I need to find U plus V. When I add those together, negative 344.72 plus 30 is going to give me negative 314. 0.72I. And then it's just going to be minus 289.25J. I got to find the magnitude. The magnitude will be the speed. Okay. That'll be the ground speed, what it's actually traveling with the effect of the wind. So you get the square root of negative 314.72 squared plus negative 289.25 squared. And I'm not even going to bother with the negative because it's not going to matter. And I'm going to take the square root, 427.45. And that will be its speed. All right, here's where you got to watch. We're going to run into some case issues here. How does it want the answer written? It wants the speed and the bearing. We just gave the speed. Okay, that is fine. The bearing, though, the bearing has to be in this format, 70, like south, 50 degrees west. Okay, yes, that's a direction of 220 degrees, but this asks for a bearing. Okay, on this problem right here, if you just take a look at that final vector, okay, the bearing will be south and whatever this angle is west. But when we do inverse tangent, okay, that gives us the reference angle, which is right here. So when we do that, theta prime is inverse tangent, the absolute value of negative 289.25 divided by negative 314.72. Okay, I got 42.59 degrees. Okay, let's take a look. Inverse tangent, 289.25 divided by 314.72, 42.59 degrees. That's not your answer. That is right here. Nope, I lied. You're like, no, it is not. It is not right there. It is this angle right there, 42.59. We need this for the bearing. We need that, and that's going to be 90 minus 42.59, okay, which is going to be 47.41 degrees for that one. So our direction or our bearing is going to be south, 47.41 degrees west. Okay. Speed, 427.45, bearing. Now, if I asked you for the direction, which is a different answer, you would take 180 plus that original 42.59, which looks like it would be 222.59 degrees. Okay. But it does ask for bearing. You have to answer according to the directions. Okay, those are the three problems here I wanted to go over today. Here is what you're going to need to do. This is a 7-4, kind of reviews everything. Okay, it's on the modules with the guided notes. Okay, it has some problems from early convert to IJ form, and then it does have some application problems. This last one is a little bit difficult because you're going to have to read it and kind of go through it. If you don't get it or if you get stuck, don't panic. That's okay. All right, so this is Thursday. No school tomorrow. This is not due tomorrow. This is due Monday. Okay, this is due Monday. And I'll actually have it due Monday by midnight. We will have a lesson on Monday. We will start with 7-5, and then we will review Tuesday and Wednesday. I don't know if I'll present both days, but we will review, and there will be a test Thursday. Okay, that is the plans. Remember, that test is very, very important because it's 55, goes in that 55% bucket. All righty. I hope everybody's doing well. I hope to see you sooner than later. Have a great day.